Hi everybody, my name is Allison and I'm going to talk about lactate and exercise. So first let's just talk about how we get lactate. And the first thing is it comes from carbohydrates. And we consume carbohydrates in forms of food such as breads, pastas, rice, some vegetables. And once we consume that food, it turns into glucose in our bloodstream. One molecule of glucose is 6 carbons and 6 waters, H2O, 2 hydrogens and 2 oxygen and 1 oxygen. The reason why the hydrogens and oxygens are very important through our physiological processes is because we need oxygen in order to produce ATP. ATP being adenosine triphosphate, allowing us to have energy for cellular activity. It's our energy currency. So when we break down glucose to get ATP, it's called glycolysis. It's a process called glycolysis. As we can see in the photo, glucose through the process of glycolysis turns into pyruvate. When we have oxygen, pyruvate can turn into acetyl-CoA and go straight into the mitochondria and produce many amounts of ATP. Whereas when we don't have oxygen, which is an anaerobic process, it turns into lactate. We have to understand how now we can get ATP through lactate. We know that it's much easier to get ATP with oxygen. So in order to get another molecule of glucose, we have to go through a process called gluconeogenesis that is done in the liver and the kidneys. So when we break down glucose, turns into pyruvate and turns into lactate, it has to go back into the liver to form another form of glucose to go into pyruvate and then turn into acetyl-CoA for aerobic glycolysis. This is also called the Cori cycle, where we're able to, also known as the lactic acid cycle, where we're able to convert pyruvate into lactate into glucose, and that happens in the liver. So our livers and skeletal muscle contain glycogen granules and enzymes for glycogen synthesis and glycogen breakdown. Glycogen is basically stored glucose. And we know at rest that skeletal muscle has high synthase activity, but with increased physical activity, we have high phosphorylase activity. These enzymes are very, very necessary because they regulate glycolysis. So when we have anaerobic activity without oxygen, such as activities of 200-meter sprints, an all-out swim, a 50-meter swim, finishing the end of a high-intensity exercise that lasts about 90 seconds, we rely heavily on anaerobic glycolysis to produce ATP. Anaerobic glycolysis, again, does not use oxygen, and it's harder for us to get energy when we don't have oxygen. So lactate is different than lactic acid because lactate is formed from lactic acid. It basically uses a remaining compound from lactic acid to bind with a positively charged sodium and a potassium ion to form an acid salt. So that means right now what we know that we kind of have this idea that lactate isn't good for our bodies because it slows us down. It really does. So we also know that, it doesn't accumulate, lactate doesn't accumulate in our system because its removal rate is equal to its rate of production. So it provides a valuable source of chemical energy that accumulates with intense physical activity. But when we produce this lactate in our systems with physical activity, we're able to remove it at the same rate, which makes the onset blood lactate accumulation brings up. So when I talk about onset blood lactate accumulation, also known as OBLA, it's when our blood lactate concentration reaches this millimoles of 4.0. So, for instance, if we're working out at a high intensity exercise, we're unsure whether or not the lactate that we have accumulated, which it doesn't accumulate because we're able to remove that lactate at the rate of accumulation, we're able to remove it at the rate of its production, but we're unsure of how much lactate is actually in the bloodstream at the time. So our blood lactate can be different than the lactate that we accumulate while we're exercising as well. So I'll go and talk about hydrogen, because hydrogen is a proton that makes blood acidic. And we talked about how glucose is formed of carbon and hydrogens and oxygens. Luckily, when we have hydrogen, hydrogen likes to bind onto oxygen, and oxygen is something that we need to form ATP via oxidation. So lactic acid releases this hydrogen ion, and we know that this hydrogen ion can bind to pyruvate to form lactate. So we know now that lactate can act as a buffer because lactate is basically a pyruvate that latches onto hydrogen, and hydrogen likes oxygen, and we like oxygen to be able to sustain high rates of physical activity. So lactate can be used as a buffer to help the blood become less acidic by using this hydrogen ion. And the hydrogen ions can find an NAD+ that's used in aerobic glycolysis that is needed to form ATP. So overall, lactate is good for us as long as we're able to train our bodies in ways to sustain this lactate for a long period of time. So, for instance, endurance athletes that have to sustain exercise for long periods of time, cross-country runners, as you can see in the photo, some rowing athletes, also basketball athletes that have to play 40 minutes of a whole game. They have an enhanced ability for lactate clearance during exercise because they're able to uptake more oxygen, and they're able to stay at a steady rate of exercise for a longer period of time. And that's basically the gist of it, is if we're able to train our endurance and our cardiorespiratory system, we're able to remove lactate better because lactate is removed at its rate of production. And that is it.